Okay, so let's talk about the algebraic properties of equality, which are basically some properties that we can use to do some basic algebraic operations that help us solve equations. That's when we use these. We use these when we're solving equations. You have been using these for years and maybe not realizing it. It's stuff that you already know how to do. We're just putting a name on it, sort of a justification for why it's allowed that you do that, okay? So let's look at them a little bit more in depth. The first thing I want to look at is the first four of them. Notice all of the first four have a certain phrase in common. Now, they're not the only ones that have this phrase in common, but all of those first four say the words property of equality. And the only thing else they say is addition, subtraction, multiplication, and division, which are the basic four operations we do in all of math. Okay, so we have the addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. And basically all of them are saying if you start out with some equation, and it can be anything, that's what A equals B represents, anything where you have an equation, one side equals the other. And then you add the same thing to both sides, that's allowable by the addition property of equality. If you subtract the same thing from both sides, that's okay because of the subtraction property of equality. If you multiply the same thing times both sides, then yes, it's still equal, it's still all good because of the multiplication property of equality. And finally, this one is saying if you divide both sides by the same thing, that's okay. In other words, these are all the rules that you've been using to solve equations ever since you first started solving equations. Sometimes teachers call them the golden rule of equation solving. Do unto one side what you would do unto the other side. Kind of like to treat your neighbor the way you want to be treated. And that's all they are. It's just that rule. Whatever you want to do is fine as long as you do it to both sides. It's just broken down into specifically what's happening to both sides. Addition, subtraction, multiplication, division. All right, that's our first thing. All four of those. Then distributive property, I think most people are pretty familiar with. Distributive property, and we don't usually say much more than just distributive property. We don't say of multiplication over addition or over subtraction. But that's what it really is you're distributing something times, and then there's addition. So you have to multiply times each of the two things you're adding. Or you're doing times, and then you've got subtraction. So you're multiplying times each of the things you're subtracting. So this is just distributive property. I probably wouldn't write anything more than just distributive property here. And by the way, up here, very often for these, we abbreviate property of equality, POE. Okay. Next, we have substitution. Substitution is basically just plugging in. If I know that like for instance, x equals 5. It says if A equals B, then B can be substituted for A in any equation or expression. If x equals 5, then that means every time I see I see x, I could put a 5 instead. So that's substitution. And again, usually we just say substitution property, or even maybe just substitution prop. We don't usually say of equality there. It is. These are all properties of equality, but we don't usually say there. Okay, reflexive, I'm just basically talking about what you have to write on your paper. Okay, reflexive property, symmetric property, and transitive property. These are properties that work for equality. They also work for congruence, incidentally. But right now we're talking about equations. Reflexive is anytime you say something equals itself. Seems kind of obvious. So if it seems super obvious, it just says this equals itself. 5 equals 5. X plus 2 equals x plus 2. If it just says something equals itself, that's reflexive property. Symmetric is if you have an equation and then you trade the two sides. So for instance, if it says x equals 3 and I want to say 3 equals x instead, I can do that. That's symmetric property. Just trading the two sides of the equation. And finally, transitive is basically, notice I have two different equations and I put them together to make one. Okay, I have two different things that are equal, and notice that in both of these two equations, I have something repeated. Something is on the same thing is on one side of both of those equations. So it's kind of like saying if x is equal to 3 and z is equal to 3. They're both equal to 3. Like here, these things are both equal to b. So if two things are equal to the same thing, in this case b, then they're equal to each other. That's what transitive says. If two different things are both equal to the same thing, then they're equal to each other. Okay, so that's just a quick overview of these properties. I want to show you an algebraic proof real quick, just so you can see what these look like in action. When do we use these? Okay, here I'm given an equation, and I'm told when I solve it, I'm supposed to get x equals 3. But I'm supposed to prove that that is true. So I'm going to show all my steps, starting with the very first step, which is what I was told to begin with, and that's that this equation is true. How do I know that equation is true? Because that was given to me, and I always trust the information I was given at the beginning of the problem. So that's my reason for that, is that it was given to me. The next thing I would do to solve this equation, I personally would probably go ahead and use distributive property to multiply this 4 times each of these things. So I do 4 times x, 4 times 5. So that's going to give me 4x plus 20. And what I just did was I used the distributive property. So I'm going to write distributive property. Okay? Next, I need to collect my x's on one side and collect my numbers on the other side. So I think what I'm going to do is I'm going to move the x's over here because there's more of them there to begin with. There's 11 of them on this side. So I'm going to go ahead and subtract 4x. And we don't show our work in a proof, but I'm going to show it real lightly in pencil just so that you know what I'm doing. Subtracting 4x from both sides. And that gives me this. And what I did was I subtracted the same thing from both sides. Anything that you do to both sides is one of those properties of equality, those POE. So this is the subtraction property of equality. Property of equality. Next thing I'm going to do is I'm going to collect the numbers on the left by adding 1 to both sides. So that, what tells me I'm allowed to add to both sides? The addition property of equality. So, addition property of equality. Now what do I need to do to get x alone? I need to divide both sides by 7. All right, and normally you would not see the work I'm doing in pencil. You just see the results, and over on the right-hand side, it tells you how we got that result. So here, if I divide both sides by 7, I'll get 3 equals x. And I'm going to say, how did I get that result? I divided both sides by the same thing. So division property of equality. The very last thing I want to do is I want to make my statement over here, my last statement, look exactly like this. This is supposed to be the finish line. In any proof, you're not at the finish line until you have it say exactly the same thing it says here. So right now it's turned around. I'm going to flip it around so that it says x equals 3, just so it looks exactly alike. And the reason you're allowed to flip the two sides of an equal sign is the symmetric property. That's the symmetric property. Sometimes people get confused between symmetric property and reflexive property. The reason that's not reflexive is it doesn't say x equals x or 3 equals 3. Reflexive really only says something equals itself. Symmetric says if this is true, then I can turn it around. And that is my algebraic proof. Let me see if I can zoom out manually, so to speak. And there we go. So this is what these are good for, is to explain our steps in solving an equation, basically. Before I let you go, there's one more thing I want to point out to you. Be very careful when you're making abbreviations. Do not ever abbreviate anything here as sub, okay? Because there's the subtraction property of equality, and there's also substitution. So nobody would know for sure which one of those you meant, okay? So be very careful that you only abbreviate things if it's very clear what you mean by that, and you're sure that your teacher is going to know what you mean. Thanks so much.